Okay, so now we can start. When dealing with, I'm going to call, whenever I talk inequalities, I'm just going to go IQ like that. It's just faster because we're going to use it quite often. We use less than, greater than, less than or equal to, greater than or equal to. Important distinctions. Instead of the equal sign alone, right? So no longer will we be dealing with just equations, it will be inequalities, right? An inequality does not only deal with the points on the line, right? It does not only deal with the points on the line, but also with points above or below the line. We indicate this. Let me zoom in a little bit. I'll try this here. Hold on. Hold on one second. We indicate this, just get everything ready, by shading the area or pane above or below the boundary line. That's also an important term, the boundary line, so we're going to underline that. Let's continue. I'm sure you don't mind a little break here and there. All right. So moving on here. The inequality negative 2x plus 4y is less than 16. Would have a boundary line negative, I'm going to copy the exact same thing, watch this, except for the inequality is going to be replaced by the equal sign. Comma, which splits the coordinate plane in two. Okay, so you'll have two planes when that boundary line is graphed. Okay. Let's talk about shading a little bit. So if you don't, if I ask you to graph an inequality and you just graph the lines and do not shade, you're missing a concept, right? So you got to make sure you include shading, right? So we have regular shading, Okay. And what that means is we shade true region. Then we have what I call, this is me, this is not in the textbook, but we will end up using reverse shading quite often. Reverse shading is where you shade the false region. So that's important when it comes to shading. Remember that. I usually tell you what kind of shading to use, but you will notice that it doesn't really affect the ultimate outcome. It's just easier to see your solution region when you use reverse shading, especially when you're doing systems. I will put a note here. Textbook uses regular only, but it will not make your answer wrong, and you'll see why. Okay, so here's an example. I'm going to have them side by side. I'm going to have two graphs. Okay, so regular shading, and this is going to be reverse shading. And this is just a sketch, okay, so there's no specific coordinates that we're going to have this going through. So if you have a ruler, take it. If not, you can just wing it. So let's make our two coordinate planes. And they're basically copies of each other, okay? So we're gonna talk about the exact same line, exact same inequality. So we're gonna draw a line. So I'm just gonna draw it like this, right about there. And I'm gonna copy that. So I'm gonna try to keep that pitch and just copy it over to here. So they're copies, but in one scenario we used regular shading, and the other one we used reverse. Watch this. This line, the red line, created two panes. We call that right. This is a pane above it, and the pane below it. And so let's write true here. And if there's a true region and it's above, then below it is assumed to be the false region. And so since we're talking about the exact same inequality, true and false would be in the same exact place. So regular shading, what we do is we shade the true region, and this is where coloring between the lines comes back, right? You thought, when are we ever going to use this again? Right here in grade 11, who knows? Right, there you go. And on the reverse shading, like let's say another student was told use reverse shading, you actually shade the false region. And whatever went over a bit, it just there. But I'm actually going to highlight true region there, true region there. That's what I always want you to focus on. Where is the true region? Because that's going to be our focus, okay? I will call this the boundary line, right? Boundary line, same here. think you get it, right? Boundary line, and so we shade, we used reverse and regular shading. So I don't know if you want to underline that. All right. So that's all regarding shading. Now, this is a very important. This will be boxed in and highlighted when multiplying or dividing an inequality by a negative the inequality symbol flips. Very important. And if you don't, I would somehow indicate this in on my study sheet. Okay. Multiplying or dividing an inequality by a negative, the inequality symbol flips. And this is what I mean by that. Let's say a very basic example so you can wrap your head around this. Let's say you have 2 and you have 5, let's say. Which one of those two is the greater number? And you would all have to agree it's 5, right? So in this case, the inequality symbol would be like that. Okay? But what if I were to divide both of these by -1? Two divided by -1 turns to -2. 5 divided by -1 turns to -5. Which one is now the greater number? -2. So you actually, the inequality, notice that it used to be pointing this way. Now it's pointing the other way, right? So when you divide by a negative, you must do this. You must flip, right? Inequality symbol flipped, right? And you do that to keep that statement true. If you wouldn't have done that, it would have been a false statement to make, right? So we need to do that to keep that true. So I'm just gonna, right, just arrow. There we go. That's that. This is to emphasize the point. Same thing would happen if you multiplied it by a negative. So keep that in mind. Good. I'm going on the back side here. Dashed versus solid boundary lines. If you have this or that, it's a dashed. And if it's this, like less than or equal to, and or greater than or equal to, it's going to be a solid boundary line. And what that means is if you have a dashed line, that means that I'll put a note here. Points on the line not included. If it's dashed, the boundary line is there, but the points on that line are not to be included as part of your solution. And then here, right, points on line are part of the solution. So points on the line are also part of the solution. That's what that means. This is perhaps also worth boxing in. Determining the true region. And this is the short method, shortcut. I'm showing you the quick way of doing it, then later I'll show you the longer way of doing it. Okay? So for this to work, right? So note, you must rewrite inequality prior to doing this. So watch this. If you leave one line blank and just put like over here, true region, and then I'm going to have a bunch of scenarios. So if you had y is less than or y is less than or equal to, it's going to be a little bit of a table, right? This or that. If you end up with this or that, the true region is below the line. Okay. If you had y is greater than or y is greater than or equal to, the true region is above the line. And here, this is another one here. If you have x is less than or x is less than or equal to, the true region is left of line. Because remember, x equaling a number is a vertical line. Okay. If you have x is greater than or x is greater than or equal to, the true region is right of line. I don't know if you want to split this, right? This is on a much smaller version, definitely study sheet material. If you have this on your study sheet, you can always go back and don't have to guess, because if you have to guess, your whole graph could be off. If you get this wrong, you shade the completely wrong pane of the graph, and that would be a pain to correct, right? So you don't want to do that. So let's graph one of these, shall we? Graph the following. Yeah, if you only have a couple lines left, I would suggest you start a new page, because we're going to graph and do a bunch of rewriting and stuff like that. Graph the following inequalities. Now you're happy that I changed it to IQ, right? Because it's always going to happen. And we're going to assume we will use regular shading. If you're ever not sure, just ask me, and I will tell you how you can always be sure to get it right. So the first one is 4x minus 5y is greater than 10. And the first step is find intercepts. Okay, because if you want a graph is just like a line, we're going to focus on the boundary line. Okay, so when you have this, the boundary line is 4x minus 5y is equal to 10. So for just a moment, we're going to forget about the inequality, just focus on the line. And I will ask you to find the intercepts. If you want to graph and have the least amount of issues with your graph, find the intercepts. That's my preferred go-to method. You should know that x-intercept y is equal to 0. So it's just 4x. This turns into 0, so it's just 4x is equal to 10. You divide both sides by 4, x is equal to 10 over 4, which is 5 over 2. You don't have to reduce, you know that already. That is actually an exact value, and I would always recommend when you're finding your intercepts, round to 2 decimals, because it's easier to find it on your graph as opposed to keeping it as a fraction. So you just found a point. I don't know why I put the 0 there, folks. It's just 2.5, 2.50, same thing. You just found that intercept. And believe me, when you're graphing 3 of these, intercepts are your friend because they help you figure out the scale. So x-intercept and y-intercept. So technically x turns into 0, so that turns the 4x completely to 0. Don't forget about any negatives, because if you get that wrong, again, it's tough to correct. And so 10 divided by negative 5 is negative 2. So 0, negative 2 is the x-intercept we're after. I always like to box this in. And trust me, later on, I actually cut a lot more. I'm a lot faster, just going straight to the point. You don't have to show that much work. So this is step number 1, so to speak, right? And my second step is to rewrite it. You know what? I don't want to give up this space. So I'm actually going to go up a little bit. So I want to. Okay, so up here is rewrite. Rewrite inequality, folks. I now forget about that line. I'm back to my inequality. And so it works the same way as an equation. Watch this. I'm going to keep the negative 5y here. And the 4x will come over, cross that inequality symbol to the other side, and the sign changes. So you keep that inequality there. The 4x comes over negative 4x, and the 10 is already there. So you just tack it on like that. Now we need to divide by negative 5. Warning, warning. What happens when you divide by negative? The sign flips. So do that first. I'm going to go over here, and before I forget, I'm going to flip the sign right away. Right on the side here, flip. Oops. Flip sign. Okay. And then I'm going to just write the y here. Negative 4 divided by negative 5 is just positive 4 over 5x. Positive 10 divided by negative 5 is negative 2, which, by the way, if this doesn't jive with this, right, then you did something wrong. You got to go back. One of these two is wrong. Okay. Why am I saying that? Because a lot of folks forget and just go plus 10 here. They forget to divide. You should get the same y-intercept. Anyways, where's the true region here? Now let's go back. It looks like this, right? So the true region is below the line. But watch what I'm going to do here first. Is this dashed or solid? It's dashed, so I always do this. Dashed. Later on, I'll just go D, right? So dash, true is below, and we're gonna shade below because the true region is below. Sorry, I'm fast forwarding here too much. You're gonna be like, what did he just do there? Sorry. True region is below, shade below. Later on, I will shorten it, but for now, you need to see the whole thing. Why is the true region below? I'm just looking at the sign and Y is isolated. That's how I know. Why am I shading below? Because I'm shading the true region, which is below, right? So in this case, they match. And now let's go ahead and graph. I will try to make this work because I know that I can. So X and Y. I need 2.5 zeros. So 1, 2, 3. That's good enough. So 2.5 is going to be there. And then 0, -2 is right there. Okay. And bless you. Before I graph, it's dashed, correct? A lot of times you forget that and you go, right? Easy to make it dashed, right? Just erase here and there. I will honor that. Oh, it just happened to me, right? So you're like, oh, dashed after all. Right? So you need to make it dashed. And then I'll fix that here. And then you label, you say that this is very important. If you want to get it right, just say that the true region is below the line. So if this is the line, true region is below it, right? And we're going to shade that one. So as long as you tell me where the true region is, that is what matters to me. That is ultimately what we're after. It's like, do you know where the true region is? And so by default, what is above the line? It's all false, right? So, but that one I'm not so keen on. You don't have to tell me the false. You don't have to really label. Just make sure the true region is there. And last but not least, label your inequality. And you have yourselves an inequality graph. Okay, so it's basically a line with the added shading component. Okay, let's do a couple more. How about this one? So this is B, 3x is less than x plus 4. No, let's go plus 6, sorry. What if you had something like that? Okay, when it is like this, you should always scan first before you just go ahead and do work. It's not always going to be the way I just showed you. Here you realize there's only one variable, right? Only x present, right? This is going to be special case, right? This is going to be x is equal to a number case, right? So it's a vertical. You should recognize that this is talking about a vertical line, right? So I won't go through the x-intercepts and y-intercepts. All I will is rewrite. And I go 3x. The x that's here comes over negative. I'm bringing it over to the left because I want to simplify it, right? You want to combine like terms. Does that ring a bell? Combining like terms. Remember when you FOIL things? You need to combine like terms. Same thing here. You're like, foiling? I don't remember that. Well, then that's what you did in IPR. And then you divide both by 2. Do I need to worry about flipping the sign? Nope, it's a positive. Don't worry about it. Okay. So x is less than. In this case, it's not. It's a perfectly round number, right? So it's 3. You're done. This is as easy as that. So you first of all you say dashed. It's dashed. That's the first thing I would suggest you identify. Dashed. And then I'm going to shade, true, get your facts straight. True region is where? Based on the legend that I just gave you. X is less than, I always think of the negative, right? So it's to the left. So I'm going to shade left as well. So right now, because we're using regular shading, the true region and the shading region will match. Okay? And because this is a fairly easy graph to do, I'm just going to use this little section here. I can actually just focus on the positive side, right? X and Y. So 1, 2, 3. And make sure it's a dashed line. True region is here. It's actually everything going to negative infinity. All of that is the true region, right? So just feel free to go there. And then I just label this x is less than 3. Or you could label it 3x is less than x plus 6. It's up to you. I'm going to ask you a question here. Is 4, 7 part of the solution? Is the point 47 part of the solution? Just look at the graph and the coordinate. Where would 4, 7 be approximately? This is 1, 2, 3, 4. And then 7 is up here somewhere, correct? It's not going to be part of the solution. Do you agree? It's in the false region. How about for now, baby steps, right? I have to make sure I make sure you know that's false. So we know just by looking at the graph that it's not going to be part of the solution. Okay, check. So I want you to check this way because you're not always going to be given a graph. Okay, so you go 3 times 4 because x is equal to 4 is less than, I'm going way back to the original by the way, 4 plus 6. I've plugged in, if you go up, if you see where my pencil is up here, I've plugged in 4 there and 4 there. Wherever there was an x, I plugged in 4. And you might ask, what about the y, Mr. Dirksen? There is no y in this inequality, so you just don't worry about it. So this is 12 is less than 10. And now you got to make a decision. Is this true? Right, statement is false. Is false. Therefore, 4, 7 is not part of the solution. That's how you would answer a question. If I ever ask you, is a particular point part of the solution? Plug it in, and then you check for sure. Okay. Okay, so that's how we graph. Here's the other part. Writing the inequality from the graph. And so here I have to kind of give away the graph, right? So we're going to try our best here. You want to make sure that you go to -5, so 5 in each direction, okay? And you got to try to make it as accurate as possible. And remember, the scale can differ from the X and the Y as long as it is consistent within. So try your best here. So we're going to go 1, 2, 3, 4, 5. And I'm doing the same thing in the negatives. 1, 2, 3, 4, 5. And then I'm using my lines here. 1, 2, 3, 4, 5. And I'm going to be specifically telling you some points that I want you to plot on it. So I'm going to give you a little bit of time to get that all ready. So I want you to find 0, 3. Put a point right where 0, 3 is. How about we label it 0, 3, just to make sure. And I want you to go find negative, so -2, 0, like here. So those 2 points are very important because if we have 2 points, we can find a slope. And we're going to go solid line here. So connect those 2 points and just graph a solid line. And I will tell you that the true region is above it. And because we're using regular shading, we're shading above. By the way, if I asked you before, I just gave it away. But if you see something like this and I asked you what kind of shading has been used, regular or reverse, you would have to say regular shading, right? Because the true region has been shaded. Okay? You would have to say that. Okay, so here are the steps on the side that I want you to follow. Step 1 is find the slope. Find slope and y-intercept. Determine the true region, right? Determine true region. Is it solid or dashed? And then just write inequality using this, and this may vary, right? That inequality, don't say it's always going to be less than, right? That will depend on the situation. So let's go ahead and do that. So for our first thing, we need to figure out the slope, which is rise and run. Mr. Slope comes in handy here. This is rising from left to right. Look at it, left to right, it's going up, right? So my slope is going to be positive. No worries about negative, okay? And then you need to pick 2 points that are perfectly on the grid. So no decimals or anything like that. And so in this case, you're going to rise 1, 2, oh, I'm going to cut through the true there, but I'm going up 3, right? So my rise is 3. And the run to get to that second point would be 1, 2, okay? So you've determined between those 2 points, sometimes you can reduce that fraction. I really don't care, right? If it ends up being 10 over 5, right? 10 divided by 5 is 2, right? So that's okay. And then the y-intercept, just look at your graph, right? It's right there. It's 3. So you've essentially found, right, the 0, 3, right? The 3 is your intercept. That's B in a sense. It could be negative. It could be a number of things. In this case, it's 3. Question 2. True is above. So because true is above, it's going to be y this or y this, right? It's going to be one of those two for sure. 3, it's a solid line. So it's going to be y is greater than or equal to, right? So you've narrowed it down from the 2 candidates to just this one. And then now we're going to write. So you go y is greater than or equal to, and then I take my slope, x plus 3. This is it. And so how would you be graded for this? The inequality symbol is actually half and half. So first of all, it needs to be pointing the right direction, and it needs to be dashed or solid. Half for the slope and half for that. So you get 2 marks for something like this. Okay. And that is, I'm just going to do one more here. So let's just, this one we're just going to do the special cases. I'm going to do 2 graphs and 1 here. So let's go 1, 2, 3 here, -3, and make a dashed line like that. And we're going to say that true is here. I'm actually just going to graph 1 here. Otherwise, you're going to be like, so graphs like these, you have to kind of just be aware, right? This is a vertical line. Okay. So you know it's going to be x. The true region is to the right. So it has to be greater than. And then you have to ask yourself, is it solid or dashed? So if it's solid, you would add the equal sign. In this case, we don't. And then you just look at, this is -3, right? So this is greater than -3. That's it. So no intercept, no, right? You don't need to find the y-intercept. When it's a vertical line, it's just a special case. Okay. I wanted to do 2 and 1, but I'm not going to do it. So here's one more. Just, you don't have to make this look pretty. Okay. What if you had a solid line here? Let's make it -4. Let's make this -4 here. And we make this true. Everything above that line is true. And this is my x and y axis, right? So it's a horizontal line. You should recognize that right away. So it's going to be y and a number on the other side. In fact, we can put that number down already. It's going to be y and -4 on the other side. Now you just need to figure out what goes in as my inequality symbol. So true is above, right? So I need to make sure this is like this. And it's a solid line. So I need to add the equal sign like that, and you're done. So special cases are actually very easy to do. No slope, no intercept, right? I mean, they have intercepts, but it's easy to find. And then you're done. I'm debating whether or not I should do one more. No, I will just do this. And you can start today. I should say that, you know, the first booklet with the calculator in the front? That one is, we're done with it. Now you use the thicker one, okay? Looks like this, okay? And I want you to go straight to pages 2 and 3. Just so you know, I want you to graph all of them. And there's also graphs, and I want you to figure out the inequalities for them. My key probably does it a little differently, but your final answer will be the same as if you follow my steps here, okay? So just focus on that. Okay. So pages 2 and 3, you can start today.